How do we measure if a network link is congested, and how does that affect a packet's journey? Today, we analyze traffic intensity and calculate total end-to-end delay. Traffic intensity is the ratio of the rate of incoming bits to the link's transmission capacity. It is modeled as L times A, divided by R, where L is packet length, A is arrival rate, and R is transmission rate. When intensity is near zero, queuing delay is negligible. As intensity approaches 1, queue sizes and delays grow exponentially. If intensity exceeds 1, the queue grows infinitely, causing massive packet loss. The total end-to-end delay of a packet traveling through a single hop consists of 4 parts: nodal processing, queuing delay, transmission delay, and propagation delay. Let's see them sum up. Let's trace a packet crossing a link. Here, processing and queuing delays are 5 microseconds, transmission speed is 1 gigabit per second, and propagation speed is 2 times 10 to the 8th meters per second. To find total delay, we compute transmission delay as 8 microseconds, propagation delay is 1 millisecond, and processing queuing is 5 microseconds. Adding these up yields exactly 1.013 milliseconds.